Okay, so today is chapter 3, lesson 8, and today we're learning sets and maps. And this is a really long lesson and might be complicated, so just make sure to pay attention and I'm sure you'll be fine. So the first thing we're going to go over is hash set. And just note that to do everything in this lesson, you're going to have to import java.util, just like you did with ArrayList. So just to keep in mind, that's still something you have to do. So what a hash set is, it's an unordered set that can't have two elements with the same value. Unordered meaning that it's random in its placing of values. So unlike ArrayList, where it has indices, for hash set, there's no indices. So it's really just random with its placing of values when you add it in. So note, for all of these following types of data collection, you are able to print it out using a print statement and the name of the collection, like with lists. But just know that it might display differently. So some do it with brackets, like the square brackets, like with the array lists, and some of them do it with curly brackets. So general implementation of hash set is this following. And you can notice that it looks pretty similar to the array list. It's just a different name. And yeah, that's about it. Yeah, so values are compared using the hashcode method and the equals method. And we'll be discussing that a little bit later on in this lesson. So hash set methods, of course, you can't always just have a data collection without any methods or else it wouldn't do anything. So these are a few methods. So the first one is int size, and that one you should be pretty familiar with from array lists. And of course, this just returns the number of elements in the set. Second one should be familiar with add, adds object if it doesn't exist already, and returns whether the object was successfully added. Next one, contains, again, should be familiar, returns whether an element in the set has the same value as O. And this is compared using equals and hash code, which again, I'll be going over later. And remove, and this removes an object with a value of O from the set if it exists, and returns whether if the element was removed or not. And again, should be reviewed. So example of hash set. So you can see here that I created a hash set of integer. And here I printed out a.add and then 33. A.add 34. And then in here I remove, okay, so I should probably go through. So going back to here, so it becomes true since there hasn't been a 33 before before this. Sorry. So it outputs true. Adds 34. It comes to here, and there is a 34, so it removes it, so that outputs true. This a.add, since there's no 22, it outputs true. Dot contains, it does contain a 34 from back here, so that is true. Adds 33, and then we print out the a.size, and that's because, so first you have the 34, and then you have the 22, and then you have the 33 again. So that would be 3. And you can see here that when we print it out, it goes on square brackets, just like array lists, and it has 33, 34, 22. And just notice like the random placing. So before we added it in the order of 34, 22, and then 33, but it's not the same, right? You can see that even though we added it first, like it's above the other two, 34 is actually in the middle this time. And we didn't do any changing any here. So again, like I mentioned, it's random. So it means that it just places it down randomly wherever in the set. Okay, so hash code and equals. So since all numerical and string values have good hash code and equals methods, they're like programmed directly into them. So there won't be any problems when you have hash sets of those types. But if you are creating a hash set of a class you made, like a custom class you made, then you would have to override the hash code and equals method in that class. So the equals method is used to make sure that a hash set doesn't have a repeated value. And that should be familiar since we went over equals already. So there's not gonna be an example of how to program that since you should be familiar with it already. So hash codes, a little bit more about hash codes. So hash codes are numbers that are assigned to values to keep them separate and unique. Kind of like memory addresses, but not really. And they're kind of like indices in a way. So with classes, they sometimes get mixed up when you're creating them. And so that could cause errors with comparing things. And so values that have different values should have different hash codes. And hash code, when you create it, helps minimize the chances of values that have different values, but the same hash code. So it's optional to do this, but it does help reduce runtime and the number of errors in the code, potential errors, that is. So example of hash code. Again, I'm not going to show equals since you should be familiar with it already. And so this is an example of hash code. And you can see here that we're returning an integer and then have the name of the code, name of the method. So in here, we're returning this random number times a plus b. This a plus b is like a variable. So think of these as variables inside of the class. And so the number can be anything you want it to be. The number I mean is this. But it should be a large number and also be better if it was prime, so that it's unlikely to cause a number to have the same hash code. So what this does, since there's a thing in Java where you can use a method to call another method, when you're creating a hash set, you're adding things into it, every single time it does that, it's going to call this hash code method. And when you're doing it, when you're overriding it in a class, you're basically giving it a new thing to run, and it's going to run this one. And for these, again, just make this number anything you want, but it has to be big and better if it was prime. And then this part, it's not really necessary, but it's a good way to, I mean, yeah, it kind of is necessary. But it can be whatever you want as long as it makes it so that there's a way to differentiate between the values. Since if you're creating objects of a class, you're not necessarily going to have same variables values each time. So by doing this, you're minimizing the chances of the classes colliding. Tree set, okay. An ordered set that can't contain two elements with the same value. The implementation is the same as hash set, except you just replace hash set with tree set. So just notice here, the difference between those two, hash set and tree set, is the fact that this time tree set is ordered. That just means that there's an order to it this time, except rather than just placing things randomly. And like you'll see in a second. But so values are compared using the compare to method or by using a comparator, which will be discussed later on in Java 4. So the only advantage of using a hash set over a tree set or lists is that it requires less time, little time to run each operation. So like by operation, I mean methods. And so for strings, symbols take precedence over capital letters, which take precedence over lowercase letters. And for numbers, they order according to regular value size, which is like 1, 2, 3, 4, 5, 6, 7, and so on. Tree set methods. So some of these are pretty similar to other ones. So there's size, there's add, there's contains, there's remove. I'm not going to go over it too much. And more methods. So these are new. So this one's called first, and this returns the least element in the set. And so since tree set orders has an order, that means there's always going to be a least element, the first element, basically. This is called the first element, basically. So it returns the very first number element in the set. Last, it returns the greatest element in the set or the last one in the set. Higher, and then you have a value. So this returns the least element strictly greater than val. So basically, the value entered here, it's going to return the one that's one greater than val, or strictly greater. So that means that it can't be equal to val, it has to be strictly greater than val. Ceiling returns the least element greater than or equal to val. And this one's a little bit more lenient than higher. So it can be either equal to or greater than. Lower, and this returns the greatest element strictly less than val. So that's like, again, strictly less. So that means that it can't be equal to, it has to be less. Floor, less than or equal to. So you can notice here, if you want to have a way to remember these better, you can think of it as like higher, lower, ceiling, floor. So that makes it kind of easier. And then first and last, it should be pretty easy to remember. So note, tree set organizes from least to greatest by default. So that means the first element for a numbers set, would be the least value, so the smallest number. And the last number in the set would be the biggest in value. Same thing with strings. The least one, like the smallest one technically, would be the first element, and then the greatest one would be the one with the more symbols technically this time. But yeah, there's the reason why I'm saying this right now is because there's ways to change how it's ordered. So you can change it to greatest, least, odds and evens, but that will come later. So I'm not gonna go over it right now. Tree set example. I don't know why that's cut off. Okay, sorry. There should be like, okay, that's an error on my part. There should be like a tree set implementation thing. I don't know why it got cut off. So first, pretend it's a string tree set. It's an a.add, ABC, a.add, hello, a.add, and exclamation mark. So first we remove hey, but there's no hey in this tree set, so it returns false. A.size, and we have 3 here, so that returns 3. A.last, that returns the last value, which means the greatest value. So that returns, sorry, wait. Oh, sorry, by last I meant like the least value, sorry. It returns ABC. First means the greatest, so that returns exclamation mark. So just notice here that even though I entered it in this order, okay, so I should probably get this, sorry, it's a little bit messy. But anyways, so we were on a.first, that means greatest, so that's exclamation mark. So a.higher, BCD, so that means you want something that's strictly greater than BCD. So in this case, it would put out null. A.floor, hey. This would, again, with floor, it means that it can either be equal to or less than this. So that would be ABC, since ABC is technically, anyways. And then lastly, we print out A, which is the set name. And you can see that despite ordering it like this, sorry, I got it incorrect, but like it goes from greater to least. Yeah, I should probably edit this, sorry. There's a lot of errors, but they'll be fixed later. So despite entering it in this order, it actually orders it like this, where it orders this symbol first, and then the capital letters first, and then the lowercase letters first. Sorry, not first, but in order like that. And that's what I mean by symbols take place over capital letters, which take place over lowercase letters. So it's really all based on, it's kind of like ABC sorts where you used to do as a child, So yeah, you're just going by number by letter by letter to see which one's bigger. Hash map. So there's 4 in total, 4 data collections. And so this one is called hash map. And this is an unordered map that maps keys to values. So this is similar to a dictionary and also a little bit similar to a hash set. Yeah, again, it's like a dictionary, and for a key, for like a word, which is like a key, it has like a definition, which is a value in this case. And the reason why it's a bit similar to hash set is the fact that it's unordered. And yeah, it uses some of the same methods that you use for hash set. So each key can only have one value, though many keys can have the same value. And keys and values are compared using equals and hash code method. So how to create one is this. Just notice here the main difference is the fact that you have a second input now instead of just one. That's the main difference besides the name change. One way of using a hash map can be if you wanted to create a hash set to that recorded how many times a value comes up. The key would be the element, and the value would be how many times the element came up. So basically, you could do, if you had like a string, string value. Oh wait, sorry. So in this case, if you swap these two, you would be able to calculate how many times a value comes up. So you could start off with a key here, like a string, and then 0 in the integer part. And then every single time you go through and you find a value, then you can increase it by 1. And that's how you could also record stuff like that. Hash map methods. So size returns the number of key to value mappings in the map. Put, which is different from add, but the name is different at least, but it's similar. You take a value here, a key, and then a value, and then maps the key to the value. So it overrides previous mapping if it exists. Yeah, basically similar to add. So get object key. So you're taking a key in here that you want to find. So it returns the value the key is mapped to, or null if that doesn't exist. Contains key. You're taking a key, and you're returning whether that key is mapped to a value. Contains value. You're taking a value, and you're returning whether a key is mapped to that value. Hash map methods continued. We have put if absent, which you take a key and a value, and that maps the key to the value if the key is not already mapped to any value. If the key is mapped, then it returns the value of the key, like the current value of the key. Remove, taking in a key, and you're removing the mapping from the key to its value if the mapping exists. Remove, and this time you're taking 2. So it removes the mapping from the key to the value if the key is already mapped to the value. So in this case, these two have to match each other for it to be removed. Replace, taking key and value, maps the key to the value if the key is already mapped to a value. And entry set returns a set of map.entry, KV, where an entry is basically a pair. So this is kind of like just printing the hash map name out, like the collection out, except it's a little bit more ordered, I guess. And lastly, values. It returns a collection of the values in the map. So only the values. So not the key, not the key and the value, it's only the values. Sorry, I'm making sure I didn't miss anything. Okay, hash map example. So we have a hash map with integer, and we're putting in 3020, 2010, and 1020. So first, we're getting an a.entry set, and you can see here that it's put in square brackets, and you have 20, 10, 10, and 20, 30, and 20. And again, just notice how it's like all random, and it's separated by like the key and value pairs are locked to each other by equal signs. And then we have an a.put if absent 1030. But notice here that we already have a key here that's already 10. So it's not absent. And so what it does is it print out what the value is, like what the value is for that key already. So that would print out 20, since 10, 10, and this is 20. So 20. A.remove 10, 10 and 20. And there is a 10 and 20 here. So we remove it, and that equals true. A.entry set, we have only 2 now, and it's 20, 10, and 30, 20. A.contains key 20, and there is a key 20, so that returns true. A.get 8, and this is getting the key. So, but there's no key that has 8 there, so it returns null. And lastly, if we just print it out like normal, then it still works. It's just a different format now. So it's in curly braces now. You can see here that it's still the same. Tree map. Okay, tree map is an ordered map combination of tree set and hash map, meaning that it takes in a key and a value, but it's ordered inside of the tree map, unlike the hash map. Again, the implementation differs in that the name is replaced with tree map. Entries are sorted by key, and only the key needs to implement comparable, which will be discussed later. And like a tree set, you can also use comparator, which will also be discussed later for tree map as well. Implementation is similar to other implementations. And most of the methods that work with tree set and hash map should work for tree map. Note, however, that some methods similar to tree set require a few extra implementations, such as adding a value or a key after the main word. Well, mainly that is because it's a map now, so it's different from a set. This should be the last slide. So this is the for each loop, and we already discussed this with arrays already, so you should be familiar with this. It's just I'm teaching you like a new way to use it. So if you were only to print out the keys or only the values of a map, then you can use a for each loop. So example, if we had a tree map like this, and then we put some values in. If we did a for, and then we did map.entry and integer b. So this is kind of saying, this is, think of the map as a class in a way, and then .entry. So this is like another kind of method kind of thing. And then you're putting in the values that your tree map has, and then b as a variable name, and then a.entry set. So basically we're saying that since a.entry set turns it into an array, then that's the reason why we could loop through this. And you're basically saying that this b will take every single key and value pair inside of the tree map. And then in here, we're printing out b.getKey. Since that's the method for getting a key in a tree map. Yeah, and that will print out the keys. So you can see here that we have 10, 20, and 30. And if we just print out the tree map, you have 10, 20, and 30 here as the keys. And you can see they're all in order and they're all here. But yeah, that's it for this lesson. It's a long lesson and it's complicated as well. So it's really good to review the video and review the lesson slides again, just to be familiar with it, since there's a lot of information that goes in this. And this is the last lesson of Java 3. So you have all of it now, and it's also good to just review over everything in general. But yeah, the class problems will be there in a second. Okay, so these are the class problems for this lesson. Before you do these problems, I would probably suggest you go over either the class, like the video again, or review the lesson slides so that you're very clear on how this works and you've got it all down. Otherwise, doing these problems, you're probably gonna suffer a lot. But yeah, otherwise, if you're all good on it, then do these regular problems first, then do these challenge problems if you feel up to it. But otherwise, yeah, it's a long lesson and it's the last lesson. Yeah, just make sure you're all good on it, and I'll get on the other stuff for next week, which is a review week and a test. And so otherwise, that would be it for this lesson then.